Okay, so this is the 7th and last video in the series on decimals. So up to this point, we've talked about like what decimals are, how to write them out in words, how to convert decimals to fractions, how to round decimals. We have talked about how to write fractions as decimals, so converting all fractions to their decimal equivalent. We talked about adding, subtracting, multiplying, dividing. Now we're finally to order of operations, and we'll also end with like a little kind of a really quick explanation of estimation. Okay, so estimation is going to involve rounding. So if you have kind of forgotten how to round, you might want to go back, review by watching the rounding video, then come back to this one. All right, so let's see. All right. Okay, so order of operations. I'll go back to black ink. Okay, order of operations. Good news. The order of operations has not changed in the slightest, okay? It's the same process whether you have whole numbers, fractions, decimals, whatever, okay? So the first step to the order of operations is grouping symbols. So that could be your parentheses, brackets, curly braces. You could have absolute value bars, all right? Next step is exponents and square roots. You'll sometimes see the radical or the square roots in step 1, just kind of depends. You don't see them very often, period, but you could do them in either step 1 or step 2. Third step is your multiplication and division. And the only thing you really need to remember about multiplication and division is to work from left to right. And then finally, you have addition and subtraction, and it's the same as with multiplication and division. You want to work from left to right. Now, you are welcome to use Pemdas, or please excuse my dear Aunt Sally, to remember the order of operations. So Pemdas, I'll write it down here. So P for parentheses, but just keep in mind it does mean more than just parentheses, any grouping symbol. E, exponents, remember you can also have square roots there. MD, the only thing I don't like about PEMDAS is it makes it sound like you do your multiplication and then you do your division, and that is simply not true. You do your multiplication and division kind of in the same step, you just work from left to right. Same thing with addition and subtraction. PEMDAS makes it sound like you do your addition and then you do your subtraction. That's not really true. You work from left to right, both at the same time. Okay, so PEMDAS, or please excuse my dear Aunt Sally, whichever one you prefer. All right, let's go ahead and look at an example. Now, one thing that's going to be different about doing the order of operations with decimals is that you're generally going to have to do some side work. All right, when we deal with whole numbers, a lot of it is mental math, stuff you can do in your head. When you're dealing with fractions like we did in a previous video, or now with decimals, you might want to use some side work, okay? So let's say that we have 4.6 plus 0.7 squared minus 0.89. So I'm going to do some side work over here. All right, I don't have any parentheses that are actual grouping symbols, okay? I do want to kind of talk about that very briefly here. A lot of times when you're dealing with fractions or decimals, you'll have parentheses that are not legitimately grouping symbols, okay? So you can have parentheses that simply mean multiply. Or in this particular case, I've got grouping symbols around the 0.7, and you'll see that notation sometimes where you're dealing with exponents, but there's not actual grouping symbols. Grouping symbols would indicate that inside the parentheses, the brackets, the braces, that there's some operation, okay? So in this case, the parentheses you're seeing, they are not grouping symbols. It's just making sure you understand that exponent goes with the 0.2, okay? So really, our first step is exponents, okay? So I've got my side work. And 0.7 squared is really 0.7 times itself twice, okay? So we multiply, 7 times 7 is 49. I keep a 9, I carry a 4. 7 times 0 is 0. 0 plus 4 is 4. And then we've got 2 decimal places up here. So we need 2 decimal places down here. So this is really 4.69 plus 0.49 minus 0.89. All right. So we've gotten to the point where we just have addition and subtraction. So we'll work from left to right. So 4.6 plus 0.49. Remember, with addition and subtraction, it's really so simple that all you have to do is line your numbers up vertically where the decimal points line up, and then just fill in zeros. So we've lined everything up vertically according to the decimal point. We've added this fill in 0 over here in red. And now I add 0 plus 9 is 9. 4 plus 6 is 10. So I keep a 0, carry a 1. 1 plus 4 plus 0 is 5. And notice I dropped my decimal down into my answer. Now we've got one final step. 5.09 minus 0.89. Again, we're going to line up the decimal points and we're going to subtract. So 9 minus 9 is 0. It kind of depends on how you look at this. There's a shortcut, but we're just going to do the whole process with borrowing and everything. I cannot take 8 from 0, so I come and borrow 1 from the 5. That makes it a 4, and the 0 becomes a 10. Okay, so 10 minus 8 is 2. Drop down your decimal. 4 minus 0 is 4. So your final answer, it looks like 4.20, but when we have zeros at the end of a decimal, we don't keep them. It's kind of like having a decimal that's not, or kind of like having a fraction that's not reduced. So if you have decimals at the end of the answer, you don't keep them. You just sort of chop them off. The only exception to that would be money. Okay, let's try another one. So let's say I have 2.4 times 3.2 minus 5 times 0.2. Okay, so let's see here. I'm going to try to do my side work down here at the bottom. Hopefully I'll have enough room. Okay, so we've got multiplication and we've got subtraction. So we've got to take care of both sets of multiplication first. So first I have 2.4 times 3.2. I'm probably not going to have enough room there actually. So I'm going to go ahead and do my side work over here. All right, so 2.4 times 3.2. Now with multiplication, your decimal points do not have to line up. In this case, they just naturally did. That's fine, but they don't have to. We're going to start multiplying. We're technically going to treat this as 24 times 32 for now. So with the 32, I'm going to multiply by the 2 first, then we'll go back and multiply by the 30 later. So 2 times 4 is 8. 2 times 2 is 4. Bless my heart. Okay, I'm done multiplying by the 2. I'm now going to multiply by the 30. So what I do is I put the 0 and 30 here, and then I multiply by 3. So 3 times 4 is 12. So I keep a 2, carry a 1. 3 times 2 is 6. 6 plus 1 is 7. I add. And then I have 2 decimal places up here in my factors. So I want to make sure I have 2 decimal places in my product. So what I have right now is 7.68 minus 5 times 0.02. All right. So let's do the 0.02 times 5. All right. 5 times 2 is 10. Keep a 0. Carry a 1. 5 times 0 is 0, plus 1 is 1. And then 5 times 0 is just 0. I've got a total of 2 decimal places in my factors. I need 2 decimal places in my product. So I get 7.68 minus 0.1. Again, I'm going to chop off this last 0. I just don't need it right now. Although really, in this case, you'll see that it's not bad to have it. So I'm going to retract that statement real quick. There you go. Because in just a minute, you'd end up putting it back anyway. Okay, so now let's look at the subtraction. I'm going to go ahead and just do my side work right here in the problem because I have plenty of room. All right, so I've lined up my decimal points. Remember, with addition and subtraction, you always line up your decimal points. All right, fill in extra zeros if you need to, and then subtract. 8 minus 0 is 8. 6 minus 1 is 5. Drop down your decimal point. 7 minus 0 is 7. So the final answer is 7.58. It's not bad, right? Kind of fun. Okay, let's just keep practicing, okay? So for this one, I have 18 divided by 0.03 minus 75 times 0.6 plus 1.4 cubed. Whoops. All right. That looks a little messy. Let me fix what's inside here. I have to prop my tablet up on a stack of books so it's high enough, and it makes it a little weird sometimes. All right, so hopefully we'll have room for side work over here. We'll see. Okay, so I've got definitely grouping symbols, the 0.6 plus 1.4 in parentheses, that's grouping symbols. I also have exponents, I have division, I have multiplication, and I have subtraction. A lot going on here. What we're going to deal with first is this stuff in parentheses. Okay, so I'm going to come over here to the side. 1.4 plus 0.6, got my decimal points lined up. And 4 plus 6 is 10, so I keep a 0. I carry a 1. And then 1 plus 1 plus 0 is 2. So I really get 2.0, or just plain old 2. So then I'm going to rewrite my problem. Now I have 2 to the third. Well, 2 to the third is equal to 2 times 2 times 2. So 2 times 2 is 4. 4 times 2 is 8. So I've got 18 divided by 0.03 minus 7. I think that was actually 75 times 8. Oh, shoot. I've written this down wrong, I think. I think this is 7.5. I'm sorry. Don't hate me. I'm too involved in this video to like start over, so we're just going to roll with it, okay? So that's 7.5, all right? Okay, so now I have division and I have multiplication, so let's look at our division. So I've got 18 divided by 0.03. If you haven't already watched the division video, please do so. I have a divisor that's a decimal, so I want to move my decimal 1 2 times. I would need to do the same to my 18, so I'd have to write it as 18.00, move my decimal twice. So what I'm really working with is 1800 divided by 3. Okay, so 1800 divided by 3. Well, 3 goes into 18 6 times. All right. Let's see, 6 times 3 is 18. I get a 0. So we're going to end up getting 600 here. So I get 600 minus 7.5 times 8. I really can't remember if that's 7.5 or 75. It might have been 75. We're going to keep it as 7.5 though. So now let's do our division or our multiplication. God, maybe I should start this video over. Geez. All right, so 7.5 times 8. Make a little tiny bit more room. All right, 8 times 5 is 40. So I'm going to keep a 0 and I'm going to carry a 4. Now 8 times 7 is 56. 56 plus 4 is 60. I have 1 decimal place in my factors, so I need 1 decimal place in my answer. So I have 600 minus 60. We can go ahead and do the subtraction right here. 0 minus 0 is 0. 60 minus 6 is 54. So our final answer is 540. If we had kept that 7.5 as a 75, we would have gotten 75 times 8, which is 600. 600 minus 600 is 0. All right, let's try another one. For this example, let's say I have 1.7 cubed plus 8.4 divided by 0.12 plus 0.021. Okay. So we have exponents, division, and addition. Let's start with the exponents, okay? So a little side work here. 1.7 cubed is going to be 1.7 times itself 3 times. So I'm going to start with just 1.7 times itself, and then once we get that product, we'll multiply it by 1.7 again, okay? So let's see here. 7 times 7 is 49. I keep a 9, I carry a 4. 7 times 1 is 7, plus 4 is 11. All right. So I'm done multiplying by this 7. I'm going to go and multiply by what we're going to consider like a 10. So I'm going to put a 0 here. And then I'm going to multiply everything by 1. 1 times 7 is 7. 1 times 1 is 1. I add. And I've got 289. And then I've got 2 decimal places here. So 2.89. Okay. Now I'm going to take my 2.89 and I'm going to multiply by 1.7 again. Okay. So we're going to treat this like 289 times 17. All right, we're going to deal with the decimals at the end. So looking at 17, I'm going to multiply by the 7, then I'll come back later and multiply by the 10. So 7 times 9 is 63, keep a 3, carry a 6. 7 times 8 is 56, plus 6 is 62. So keep a 2, carry a 6. 7 times 2 is 14. 14 plus 6 is 20. All right, so I'm done with the 7. I'm going to come in and multiply by the 10. So the 0 and 10, I'm going to go ahead and write down, and then I can just multiply everything by 1. 1 times 9 is 9. 1 times 8 is 8. 1 times 2 is 2. I add. 3 plus 0 is 3. 2 plus 9 is 11, so keep a 1, carry a 1. 1 plus 0 plus 8 is 9. 2 plus 2 is 4. And then I've got 3 decimal places up here in my factors. I need 3 decimal places in my product. So this is going to be 4.913 plus 8.4 divided by 0.12 plus 0.021. All right. So we've dealt with our exponents. Now we need to deal with our division. So I guess it doesn't matter if I use black or not. So I have 8.4 divided by 0.12. Now my divisor is a decimal. I don't like that. So I need to move my decimal 1 2 times, and I need to do the same thing with my quotient, or not my quotient, my dividend. So this is really going to convert to 840 divided by 12. So we convert to long division. Now 12 times 6 is 72. So then 12 more would be 84. So that tells me 12 goes into 84 7 times. 7 times 12 is 84. I drop down to 0. 12 goes into 0 0 times. And that's going to now give me 4.913 plus 70 plus 0.021. Okay. So now we can just add up everything. Remember, when you're adding, you want all of the decimal points to line up. So 70 doesn't have a decimal point. You always assume it's at the end. And I'm just going to add some zeros. All right. So 3 plus 0 plus 1 is 4. 1 plus 0 plus 2 is 3. 9 plus 0 plus 0 is 9. 4 plus 0 plus 0 is 4. There's nothing to add to the 7, so I drop it down. And our final answer would be 74.934. And that's it. All right. Let's see. I might want to do like 1 or 2 more. Let's do maybe, sorry, I'm losing my voice a little bit. Let's do 2 more. Yeah, we can do 2 more. Okay. I want to pick good ones. How about this one? 14.78 minus 14.62 quantity squared divided by 3.15 plus 0.85. All right, so we'll do a little side work over here. I'm not going to try to scrunch too many problems into one spot. I'll just go ahead and take my time and use a whole slide instead of trying to squeeze them. Okay, we do have 2 sets of grouping symbols, so let's deal with those first. Our first set of grouping symbols, we have 14.78 minus 14.62. Remember, with decimals, when you add and subtract, you want to line up your decimal points and then subtract in this case. So 8 minus 2 is 6. 7 minus 6 is 1. Drop down your decimal. And then 14 minus 14 is 0. So we get 0.16 quantity squared divided by, let's see, the next set of parentheses, we have 3.15 plus 0.85. All right, again, decimal points line up. 5 plus 5 is 10, so I keep a 0, carry a 1. 8 plus 1 is again 10, keep a 0, carry 1. Don't forget to drop down your decimal. 1 plus 3 plus 0 is 4. So I'm just going to write this as plain old 4. All right, so I get 0.16 squared divided by 4. So let's go ahead and take care of 0.16 squared. Now, when you square a number, you just multiply it by itself. So I get 0.16 times 0.16. And what I'm going to do is I'm going to pretend these are just 16s kind of for now, and then we'll deal with the decimal at the end. So looking at the second 16, I'm going to multiply by the 6. So 6 times 6 is 36. Keep a 6, carry a 3. 6 times 1 is 6, plus 3 is 9. All right. Now I'm going to come back and I'm going to multiply by the 1 here. So I'm going to put the 0 for the 10 down here, and then I'm going to multiply by 1. 1 times 6 is 6. 1 times 1 is 1. We come down here, we add. And I get 2.56, but I got to figure out where my decimal point goes. So looking at my factors, I have 4 decimal places. Okay. So I need 4 decimal places in my product. So I move my decimal 1, 2, 3, 4. So what we end up with is 0.0256. Whoops. Divided by 4. All right. So let's convert that to long division. I get 0.0256 divided by 4. Bring your decimal up into your answer. 4 goes into 0, 0 times. 4 goes into 0, 0 times. 4 times 0 is 0. Drop down the next digit. 4 into 2 is 0. Okay. So 0 times 4 is still 0. I get 2 left over, drop down the 5. 4 into 25 is 6. 6 times 4 is 24. I get 1 left over, drop down the last digit of 6. 4 into 16 is 4. There's your 0 remainder. So our final answer is 0.0064. And there you have it. Okay. Let's try one more, and then we're going to talk, pretty briefly about estimation. It's not something that requires really its own video, but it is something that you'll likely see in, really any math class when you're dealing with decimals. So one more order of operations, and then we will talk, estimation with decimals. So let's say we have 0.6 quantity squared plus 1.65 divided by 0.03 minus 0.26. All right, and we'll do our side work over here. Okay, so the parentheses you're seeing in this problem are not grouping symbols. That's just plain old exponents. So we've got exponents, addition, division, and subtraction. So we deal with exponents first. So 0.6 repeating, good grief. I really should have started this video over, but now it's just almost comical. So I'm going to keep going. 0.6 squared is 0.6 times itself. All right. So 6 times 6 is 36. I keep a 6, carry a 3. 6 times 0 is 0, plus 3 is 3. And then I've got 2 decimal places in my factors. I need 2 decimal places in my product. So I get 0.36 plus 1.65 divided by 0.03 minus 0.26. All right. Next up for us is this division. All right. So let's see what we have here. We've got 1.65 divided by 0.03. Our divisor has 2 decimal places. We don't like that. We want a whole number. So I move my decimal to the right twice, and I do the same thing in my dividend. So I've really got 165 divided by 3. So let's see what we get there. Give myself a little more room. All right, so 165 divided by 3. Well, 3 won't go into 1, but it will go into 16. So 3 into 16 would be 5. 5 times 3 is 15. I get 1 left over. Drop down the next digit, which is a 5. 3 into 15 is still 5. 3 times 5 is still 15. I get a 0 remainder. So what I have now is 0.36 plus 55 minus 0.26. Okay. So we've got just addition and subtraction. We can just work from left to right. So 55 plus 0.36. That's one you could really just do in your head. But if you ever have a whole number and you need to multiply, or not multiply, if you ever have a whole number and you need to add or subtract, just add a decimal and a 0 and then do your adding and subtracting. So here we're adding 0 plus 6 is 6, 0 plus 3 is 3. Bring down your decimal. 5 plus 0 is 5. Drop down your 5. And now we have 55.36 minus 0.26. All right, so one last step here. Okay, so I've got my 55.36 minus 0.26 set up vertically where my decimal points are aligned. 6 minus 6 is 0. 3 minus 2 is 1. Drop down your decimal. And then 55 minus 0 is just 55. Now, remember, when you have a decimal and the last digit is a 0, you drop that last digit. The only exception to that would really be money. So again, you don't want those zeros at the end of your decimal for a final answer. So we would write this as 55.1. And that's it. Okay. So just a quick recap. All right. When you are dealing with the order of operations, let me get a sip of water. The order of operations does not change between whole numbers, integers, fractions, decimals, any type of number. Order of operations is the same. You do your grouping symbols, your exponents and square roots, multiplication and division from left to right, addition and subtraction from left to right. We did lots of examples of this, okay? So I think we did 6 examples. All right. So now what I want to talk about very briefly is estimation. Okay. Estimation is just kind of a way of like sort of eyeballing. It's very similar to rounding. In fact, estimation and rounding go hand in hand. So basically for estimation, what you do is you take your numbers, you generally round them to a particular place value, or a lot of times the directions will say round your numbers so that they have 1 non-zero digit or 2 non-zero digits or something like that. So you're either going to be told to round to a specific place value, or you're going to be told to round so that your numbers all have 1 non-zero digit. And then you can do, a lot of times you can do mental math, or the addition, subtraction, multiplication, and division are a lot easier. So this gives you an estimate for a sum, difference, product, or quotient. And that kind of goes without saying because estimation means you're going to get an estimate. Okay. So you're not getting an exact answer, but you're getting an answer that is really close. Okay. And a lot of times this is what we do when we're like budgeting for our bills. We'll do an estimate. We'll say, okay, the last 3 months we spent close to 250 on groceries. So for this month, we'll budget 250 for groceries. You could say over the last year, our electric bill averaged $110. So let's go ahead and budget $110 this month for our electric bill. You could say over the last year, our water bill averaged around $35. Let's go ahead and just round that to $40 for this month's budget. Okay, so estimation happens a lot with budgeting when you're doing your personal finances. Estimation also happens a lot at the grocery store. You go into the grocery store, you've got a $20 bill you want to spend to get your dinner. You want to make sure you don't go over so you have plenty of money for taxes. Okay, so a lot of times we'll estimate. And when we do that, a lot of times we estimate by rounding everything up, like to the next dollar. Okay, so we use estimation quite a bit. And basically what you do is you round all values to a specific place and then perform the operation. All right, so looking at just a couple of examples, what we're going to do is we're going to basically round everything, all of the problems we do in this video for estimation. We're going to round all of our numbers so that we have 1 non-zero digit. Okay, so we're going to round all values so that we have 1 non-zero digit. All right, so let's say for the first example, we have, let's do addition and subtraction first, because those are generally the most, the easiest. So let's say that we have 24.98 plus 42.6 plus 9.2. Okay. So if we want to round all of these so that we have one non-zero digit, that means we're going to round to this first place, whatever it is. Okay. Whether it's the tenths, hundredths, millionths, whatever. Okay. So looking at 24.98. Okay. This is really, really close to 25. However, if we look one digit to the right, we have a 4, and that 4 tells me to round down. So this would round to 20. Okay, it's a close one, but it does technically round to 20. If I look at 42.6, the digit to the right is a 2, so that would tell me to round down again, 40. And then 9.2, the digit to the right is a 2, that would tell me to round to 9. And so I get 20 plus 40 is 60, 60 plus 9 is 69. And that's how you do your estimation. So by taking out all those decimal places and just having one non-zero digit, it makes it really easy to do the actual addition. What if I had something ridiculous like 65,255.91 minus 39,231.536? Okay. Now, following the same rules, we're going to round all of these values so that we have one non-zero digit. Well, that's going to be this first spot here and here. Let me do it in red. So looking at the 65,000, one digit to the right of my 6 is a 5. So that would tell me to round up. So I would say that this is 70,000. Okay. Looking at the 39,000 and change, one digit to the right of the 3 is a 9. That tells me to round up. So I would get minus 40,000. And now I can do this mental math. 70 minus 40 is 30. So 70,000 minus 40,000 is 30,000. And that's it. Okay. Now, if you're dealing with multiplication and division, they're a little more involved. A lot of times you can't do the math completely in your head. You still have to do a little side work, but it's really no big deal. So let's say that we have 40. Whoops, let me go back to black ink. Let's say that we have 43,975 times 0.7552. Okay, so we're going to do just like we did on the previous screen. We're going to round everything so we have one non-zero digit. So right here. So looking at the 43,975, I'm going to round to that first place value, which is the 10,000th place. One digit to the right of the 4 is a 3. That tells me to round down. So this is going to be 40,000. Now, if I look at 0.7552, the 0 before the decimal point does not count. Okay, so we're going to look at the 7. One digit to the right of the 7 is a 5. That tells me to round up. So this is going to be 0.8. Well, all you have to do here is really multiply the 4 and the 0.8, but we're going to go ahead and do this the long way just to make sure everybody's good. All right. So we're going to multiply all of these digits in 40,000 by 8. 8 times 0 is 0. 0, 0, 0. What's 8 times 4? Well, 8 times 4 is 32. Now I have one decimal place total in my product or in my factors. So I want one decimal place total in my product. So this is going to be approximately 32,000. All right. So even though we estimated, we're getting an estimated product of 32,000. In fact, let me use a calculator really quick. The actual total, if I were to multiply this out the long way, we would get 33,209.92. So 32,000 is a pretty reasonable estimate. And all we did was make the calculation easier. Multiplying 40,000 by 0.8 is easier than multiplying 43,975 by 0.7552. Okay. Let's look at maybe one or two more. Okay. What if I had 25.7 times 1.6? So we'll do maybe 3 more. I lied. We'll do 1 more multiplication, then we'll do 2 division. Okay. So I want to round these so that they have one non-zero digit. So looking at this first number, 25.7, looking one digit to the right of the 2, I have a 5. That 5 tells me to round up. So this is going to round to 30. Okay. Now 1.6, I'm going to round the 1. Looking to the right of that, the 6 tells me to round up. That's going to make the 1 a 2. And then 30 times 2 is 60. So 25.7 times 1.6 is approximately 60. Now, if we do the actual calculation, and I'm going to cheat and just use my calculator for the sake of time, we would get 41.12. So this is a pretty rough estimation, but an estimation all the same. Let's look at division real quick. What about, do I like that one? I do. What about this one? How about we have 646? Good grief, I was trying to get rid of the red and I went and did it again. So let's say we have 646.598, and I want to divide it by 62.26. All right, so we're looking at these first sixes. We're going to round according to whatever's to the right of that. So one digit to the right of the 6, I have a 4. All right, so that tells me I'm going to round down. So this is going to round to just 600. And then looking one digit to the right of the second number, the 6 in the second number, I have a 2. Again, that tells me to round down. So it's going to round to 60. And I don't know if you know this trick, but if you're dealing with numbers that end in 0 when you're dividing, the last zeros can cancel. So you can cancel 1 0 for 1 0 top to bottom. So I get 60 divided by 6, or 10. And that's it. All right. So estimation, you're not going to get an exact answer by any stretch. Again, let's see what happens if I did this one out by hand, except I'm going to cheat and use my calculator really quick. The actual answer here is 10.385. So an estimation of 10 is incredibly reasonable. Let's do one more division and then we'll call it a day. So let's say we have 78.72 divided by 16.4. So we're going to look at the 7 and then the 1 in the 78.72 and then in the 16.4. So looking at 78.72, one digit to the right of the 7 is an 8. That tells me to round up. So I'm going to get 80. And then looking one digit to the right of the 1 in 16.4, I have a 6. That's going to tell me to round up. Okay, so when I round up, that's going to make the second number 20. Now 80 divided by 20, if you want to do the 0 trick, you get 8 divided by 2 or 4. And that's it. Okay, so estimation, if you're looking for an exact answer, obviously estimation is not the way to go. Okay, estimation gets you an answer that's pretty close once you round your numbers to a particular place value. So oftentimes we'll like say we're going to round everything to the hundreds place and then we'll estimate, or you'll have directions like what I gave you here where I say round everything so that all values have one non-zero digit. Okay, but basically you do your rounding first, then your calculation, and that's estimation. Okay, so that video was almost comical. I just couldn't speak to save my life, but you know, it happens, it's real life. And I was too invested and I need to go to the grocery store myself, so I didn't have time to start it over 20 times. But basically, sorry, I've been talking a lot today. Order of operations is the same, whether you're dealing with fractions, decimals, integers, whole numbers, okay? You want to take care of your grouping symbols, your exponents, multiplication, division, and then finally addition and subtraction. I do encourage you with decimals to do some side work. A lot of this stuff you can't do in your head, so have a very designated area where you do all of your side work, okay? Don't cheat and just use your calculator. I promise you, if you just sit down and type numbers into your calculator, you're learning nothing and you're wasting your time and energy on whatever class you're in, okay? So really, you can use your calculator to help sometimes with little calculations, but you need to know the process. So show the work, show all the steps, okay? As far as estimation is concerned, it's something that we actually really do use in our daily life quite a lot. You round to a particular place value and then you perform your operation of addition, subtraction, multiplication, or division. So that wraps up the series on decimals. Next up, we'll talk about rates, ratios, and proportions, which I happen to like a lot. One thing I will warn you about rates, ratios, and proportions, you have a lot of decimals, not a lot of decimals, a lot of fractions involved, okay? So if you need to go and kind of brush up on fractions a little bit, do that before you come into rates, ratios, and proportions, okay? Fractions and decimals show up, but decimals are generally a little easier for students, so it's going to be the fractions that kind of give you a little bit of trouble potentially. So review fractions, and then we'll start the next series on, like I said, rates, ratios, proportions. Okay, best of luck.